instruct the rest of your immune system where to come to fight a battle. So I think we could say that if these guys just disappeared, then you would still have immune cells, they just wouldn't know where to go. They wouldn't know where to fight. You would get an infection and it would be uncurable. So having these guys would be a benefit. Good? Now, there is a time and place, or there is an instance in which these cells can go away. And the most, I guess, obvious case, or the case that would be most known, would be an individual that has, for some reason or another, is having an HIV particle in their body. HIV, of course, stands for Human Immunodeficiency Virus. Uncurable. And what's important about that virus is that it has proteins on its outside that are identical to the proteins on a human T cell. Now, what does that mean if those two proteins are identical?
Doesn't seem like it's an invader.
Yeah, it's a match. And it's beyond a match. It's beyond like avoiding it. What actually happens is the HIV cell, or I can't say that, it's an HIV particle, will come into close contact with the T cell, and one of two things are likely to happen. And we'll talk about this mechanism more and more about starting tomorrow and then finishing it up on Wednesday. But somehow there's got to be a mechanism in which the HIV and the T cell come together, and once that happens, the nucleic acids of the HIV particle are sent into the T cell. So again, let me rephrase this and make sure we understand this. You have a T cell. You have millions of them, billions of them, floating around the body with their normal T cell DNA that's coding for essentially good things. Fighting off invaders, keeping you healthy. Now, if HIV shows up, an HIV particle is going to release a small piece of nucleic acid that's coding for basically negativity. In fact, your helper T cell, whenever it is become infected with an HIV particle, whenever the HIV genome has entered into a T cell, the T cell actually loses its identity. It's no longer the helper T cell. It actually is now simply just an HIV manufacturing center. So again, what we're alluding to here is that you have these, I'm sorry, what?
Would it be a particle?
It would be a cell, because this is a T cell. This is a living cell in your body. Your body recognizes it as a helper T cell, but the reality is that deep down inside of it, it's doing negative things. It'd be analogous, going back to the example, you pass by the shop of car stereos, and you see the outside of it, and it seems like it's the normal little shop, but I'm in there, and I'm a crazy guy. Right? So, I mean, it looks like a T cell, but it's certainly not acting like one. Because T cells recognize foreign particles, they recognize where a battle needs to be, they're an immune response cell. Once the HIV genome is dumped into the T cell, and we'll talk about this dumping mechanism tomorrow or the next day, but at least for now, we could agree that once that HIV genome is inside the T cell, you could cross out helper T cell, because that's not what it should be called anymore. It's not an HIV manufacturing cell. Now, what does manufacturing mean? To produce, to make, right? And HIV manufacturing would make you help you allude to the fact that it's producing what? Okay, so now this helper T cell is going to be producing tons of these little HIV particles. And what are HIV particles going to be doing? Attacking what cells only? So you could expect that over the course of a person's life, once infected, the percent or the levels of T cells, somehow this is going to be representing the levels of T cells, is going to go into a steady decline over the time of that individual's life. That's after, of course, post-infection. And by about the 7th year, untreated, and this is a give or take, I've read so many different things on this, so many different time frames. I think I've read 7th is the most common, and don't hold me to that. But by the 7th year, an untreated individual will have minimized their T cells to a level that they're basically non-existent. And what does that mean? Well, you don't have these guys fighting your battle anymore, or at least helping you to fight the battle. So you've developed a condition that's known as acquired immunodeficiency syndrome. The individual has acquired AIDS. And at that point in time, what essentially this means is that they're not going to be killed by AIDS. You know, this isn't this virus isn't causing their destruction. Literally, what it is causing is it's causing a shutdown, a blinding effect of your immune system. So these people at this point in time are prone to all kinds of infections, like the common cold could kill these individuals, or types of pneumonia, which normally would not kill an individual, would kill an individual that is having AIDS. There's even a lot of unique conditions that we find like only in barnyard animals, basically, that these people get. And the reason for that is because our immune system is consistently fighting off those types of infections, but in that case, the immune system is shut down so much that they could catch anything. In fact, the reason that all this started as far as knowing that AIDS was something that existed in the early 80s was because these people were coming in and dying of infections that we knew existed, but we never saw anyone get. And if you had one case, okay, that's a freak of nature accident. But when you have 20 cases across about 10 different states, all within a month's time, and they're all dying of this crazy issue that we've never seen before, is a red flag. And so that's what started like this push in the late 70s, early 80s to find out what this virus was and what it was doing. And we found out it just shuts down a person's immune system. Now there's medications that can be taken that stimulate the number of T cells that you produce in your bone marrow. There's medications you can take to try to prevent this attack. But all those medications do is they prolong this time right here. It's inevitable that this decline of T cells will have to occur to an individual. This just might be 17th year now. You know, every once in a while you see someone like in the 27th year of infection, but it would make sense that this number will have to decline. Good. As far as like when does this trace back to, for sure the CDC has known that it existed in the early 80s. I've seen some graphs, some studies that trace like HIV back to like 1910, 1920. So probably somewhere around that time it came into existence. As far as like how it came into the system, no one really knows. It couldn't have been around too long, because if you think about it, you know where HIV is coming from. So if you just think about it, it can have been around. It could not have been around for too long. There's conspiracy theories on like its origin, about how it was like a government thing, or there's just probably the most widely believed scientific thing is that it was something that came from an African monkey that bit a human X number of years ago, and that human, you know, it stayed in the system in small amounts, and now it has blown up. There have been individuals that they thought had it, looking back at history, but they didn't know what HIV was at the time. Their bodies have been exhumed, and it's been proven they did have it at the time. So there were people that you read it, you know, a documented case in like 65, I think it was, of an individual that they thought had it, or they knew had something, but they didn't know what it was. That body was exhumed, and they found that, in fact, that individual did have HIV. So it's been in small amounts for a while. It just didn't balloon up into what it was until like the early 80s. But we'll talk more tomorrow about how this infection, how does this mechanism, especially with a retrovirus like HIV, how does that happen? And then what is the exact process of making more HIV particles? And we'll see that it's not just as simple as me walking into the garage with my bad idea and selling bad stuff. It's actually very complex combination of effects.